welcome to the fifth video of our calculus series. In this video, we are going to be discussing how to differentiate when there's more than one variable involved. This process is called implicit differentiation. We're going to start off with a very simple problem that most of you guys should be familiar with in terms of the equation itself, and that is the equation of a circle, which is x squared plus y squared, which is equal to r squared. However, for the basis of this video, we're not actually going to be using r squared. We're just going to be replacing that with 25. So what we're going to do here is essentially find the derivative of both sides. dx here. So when we find the derivative of x squared over here, it's simply the power rule that all of you guys should be familiar with. And this just results to 2x. 25 over here is just a constant, so it's just going to be resulted as 0. Now with the y squared here, it's a bit more fascinating. What we are trying to derive for an implicit differentiation is the y prime. And so the y squared, we're going to derive it using the chain rule, as that will give us the y prime itself. So we are going to find the derivative of y squared itself and then multiply that by y prime, which is referred to dy dx. You can refer to it as y prime or dy dx. We're just going to refer to it as y prime as it's easier to write. Okay, so the derivative of y squared is just going to be derivative of y squared through the power rule, which is 2y, multiplied by y prime. Okay, so now here what we're trying to do is obviously trying to find the y prime, so we're just going to use simple algebra. We're going to subtract 2x from both sides. We're going to get 2y, y prime equals negative 2x. And then what we're going to do is divide both sides by, not negative, but positive 2y. And then that's going to result into y prime equaling negative x over y. This is very useful as using the implicit differentiation can let us attain the slope of a tangent line, which is the basis of all differentiation problem in calculus. Okay, so now we will move on to a problem that is a little bit more complicated. Okay, so we are going to start off with a slightly longer equation. So it's going to be 5x squared minus 2x squared y minus 3y to the fourth equaling x cubed. So same thing as before, we are going to find the derivative of both sides. And when we do that, for this first side here, well, 5x squared is very straightforward as it's just a power rule, so it's going to give us 10x minus 2x squared y. Okay, so what we're going to do is we're going to find the derivative of this 2x squared, which is 4x, bracket here, and multiply that by y. That's the first part. And then we're going to add that to, we're going to leave the 2x squared, and then we're going to find the derivative of y, which is just y prime, as we've gone through from the last problem. Now we're going to find the derivative of negative 3y to the fourth, and that is simply us using the chain rule once again. So we're going to find the derivative of 3y to the fourth, which is just 12y to the third, using the power rule, and then we're going to find the derivative of y itself, which is going to be y prime. And then the derivative of x cubed is simply 3x squared. Okay, so now here we're just going to do a few more algebraic procedures. So we're going to do the distributive property here. And then we get 10x minus 4xy minus 2x squared y prime. Sorry about that. Minus 12y cubed y prime equals 3x squared. Okay. Now from here, what we're going to do is we are going to subtract 10x and add 4x to the y, both sides. Same applies to here. Okay, so when we do that, we get negative 2x squared y minus 12y cubed y prime equals 3x squared minus 10x plus 4xy. Yeah, I forgot to put the y prime. Now from here, what we're going to do is we're going to distribute out the y prime, as that's what we're trying to find. So it's going to be y prime with inside the parentheses, it's going to be negative 2x squared minus 12y cubed equaling 3x minus 10x plus 4xy. And then from here, what we're going to do finally is just divide by negative 2x squared minus 12y as we're trying to find the y prime. So this cancels out, and then we get y prime equals 3x minus 10x plus 4xy over negative 2x squared minus 12y cubed. That is our answer to this specific problem. Now with this, we can use it to actually attain the slope of a tangent line, which is the basis of calculus in regards to differentiation, as a lot of you guys are aware of. So I thank you guys for watching this video. Please like, comment, and subscribe, and hope to see you guys soon. Take care.